let's delve into some deeper properties of the graphs of logarithmic functions, and let's revisit our two graphs that we had from before in order to have an understanding of this. So what I'd like to do is go ahead and list some properties of these graphs. The first thing I want to note is that both of these graphs pass the vertical line test. So what that means is that both of these graphs are one-to-one functions, and in general, if you have a function log base b of x for any base b, then that will be a one-to-one function. Next, I want to take a look at the behavior of the graph as the x values get very close to 0. As the x values get really close to 0 for the graph of log base 1/3 of x, we see that the y values get very, very, very large. And that's indicated by this arrow here. And for the graph of log base 2 of x, the y values get very, very, very negative. In order to describe this behavior, we say that x equals 0 is a vertical asymptote of log base b of x, no matter what b is. In previous classes, when you investigated rational functions, you saw that some rational functions, such as something like 1 over x minus 1, also have vertical asymptotes. Turns out that log base b of x has a vertical asymptote at x equals 0. Now, we also have the domain and range, which are given here. The domain is 0, infinity, and the range is all real numbers. And that's going to be true for every logarithmic function log base b of x. We might as well include it in our list here. So the domain is 0, infinity. The range is all real numbers. And as we mentioned earlier as well, 1, 0 is on the graph of log base b of x. And there's another point that will also always be on the graph of log base b of x, and that is b, 1, because if you do log base b of b, this will always be equal to 1. And so the point b, 1 is on the graph as well. We can see that log base b of b is 1 if we just convert to exponential form. So we move the base to the other side, and we would see that b equals b to the 1. And since this is a true statement, log base b of b is 1. Finally, let's take a note that for log base 1/3, we have that the y values decrease, and for log base 2, the y values increase. And so this is demonstrating the following true statement, that if b is bigger than 1, then log base b of x is increasing. That is, the y values get larger as the x values get larger. And if b is between 0 and 1, then log base b of x is decreasing. That is, the y values get smaller as the x values get larger.